Hello, y'all, and welcome to Lesson 31, Structure 3.1.4 of my DP Chemistry curriculum. We're going to be talking about trends and properties of elements down a group, including the increasing metallic character of group 1 and decreasing non-metallic character of group 17 elements. So we're going to focus on groups 1 and 17 of the periodic table. We will be able to describe and explain the reactions of group 1 metals with water and group 17 elements with halide ions. So we'll talk about what that means. So before we really get started in group 1 and 17, we have to talk about what metallic character is. So metallic character is, like it sounds, the ability to act like a metal, or what is it to be a metal? So when we look at metallic character, the specific thing we're looking at is the tendency, see, for an element to lose its valence electron, or VE, and become a cation. So you'll remember from the previous lesson that cations are positive atoms or positive ions. So any element that is more likely to do this, we would describe as metallic. The more likely it is to lose that valence electron and become a positive ion, the more metallic it is. One of the things that helps guide us is that we look at ionization energy, which, if we remember from the previous lesson, is the energy required to lose a valence electron. Therefore, if we put these two things together, a low ionization energy, meaning it takes less energy to remove that electron, is proportional or equivalent to a greater metallic character. So when they are very easy or very good at losing those electrons, they are more metallic. And that can be described with the ionization energy we learned in the previous lesson. Inversely, we have non-metallic character. So it's exactly what it sounds like as well. It's things that are non-metals. And this is the opposite of metallic. So instead of losing electrons, this is the tendency to gain an electron into a valence shell. And in addition to gaining that electron, they become an anion. In other words, a negative ion. So we had ionization energy, which is losing an electron, but we also have electron affinity, which is the energy lost when an electron is added. So it's kind of that change, not just energy loss, but the change in energy. So we'll actually change that. Change or energy released. Energy released when an electron is added. And therefore, a large electron affinity is equivalent to a greater non-metallic character. So these are the two terms we're going to be using, metallic character and non-metallic character, and we're going to be talking about them in terms of ionization and electron affinity. So before we push forward, let's just take a look at our periodic table. Very rough sketch. As we move up and to the right with electron affinity, our non-metallic increases. And as we move down and to the left, our metallic increases. So these are two general trends for metallic character and non-metallic character. So if we look at the most metal elements, they're going to be here in group 1. So let's go ahead and talk specifically about group 1. another term for those was the alkali metals. So group ones are highly reactive elements because when chemicals react, the big thing that judges whether or not something is going to react is its tendency to gain or lose electrons. Because just a little aside, reactions occur, oops, occur has two C's, occur when electrons move. That could be either a gain or loss of electrons. So something that's going to lose electrons very readily would be considered highly reactive because it must lose those electrons to something. So we say the group 1 alkali metals are highly reactive. Specifically, they're highly reactive with water, and they generally follow a trend. When you react a group 1 element, which I'm going to represent as M for a metal, it's an alkali metal, you have a group 1 element solid plus water, which is usually in its liquid form. You always get the same thing. You get a metal hydroxide, metal hydroxide. That's because OH minus is hydroxide. That's what we call it. And you also get hydrogen gas. This will be aqueous because it's going to be in the water. And now hydrogen gas is very flammable, which is why you will, maybe that is an I, which is why these will generally be reactions that you see with fire because they also produce heat, which ignites the hydrogen gas. Uh, this is always balanced the same way because group ones always have a charge of 1 plus in their ionic state, and it looks a bit like that. So this reaction is how they react. Now, the part about this that gets really interesting is as we move down the group, we notice that the metal provides or gives its, nope, its electrons to water, therefore creating that reaction. And because it's giving its electrons to the water, we can say, therefore, the more reactive species are the elements with a lower ionization energy, meaning they're more likely to give that electron up. With all this said, we can say group ones, group 1 elements increase in reactivity down a group. So as their ionization energy goes down and their metallic character increases, their reactivity will increase as well. So that's group 1, or alkali metals. After that, we have group 17, which sometimes is referred to on a periodic table as group 7A, but it's group 17, and these are our halogens. So these halogens, something to always remember is that these are mostly diatomic. Remember that means they come in pairs, come in covalently bonded pairs. And also just remember these are HOFINBr and Cl, the halides specifically being, or the halogens specifically being fluorine, iodine, bromine, and chlorine. Those 4 are all halogens. All right. So these all have very high non-metallic character. And you know that because they're in the far right. And furthermore, we know the noble gases over here don't really count for non-metallic characters because noble gases will not gain any electrons because this is based on electron affinity, and we know they do not have an electron affinity. So these tend to gain electrons. We know that because they're non-metallic. And the general trend is that Electron affinity decreases down the group. So as you go from the top to the bottom, the electron affinity decreases. Therefore, reactivity also decreases down the group, meaning fluorine is going to be our most reactive halogen. And we can look back at our group ones and realize francium is our most reactive alkali metal. Something to note about them is that halogens also have a common reaction. Specifically, halogens usually perform what the IB calls displacement reactions, but you may have another name for it. You might think about them as single replacement. Single replacement is usually what's taught in BC curriculum, AP curriculum. It's generally the early term when you are just swapping it. So that's basically where a reactant, specifically the halogen, replaces an element in another reactant. So we'll go over an example. We can look at chlorine gas, or actually, let's have this chlorine dissolved in water, so it's aqueous, and we react it with, let's say some metal chloride, let's say sodium or metal bromide, NaBr, which is also going to be aqueous. As chlorine is more reactive than bromine because it has a higher electron affinity, what it will actually do is replace that bromine. And we get NaCl, table salt, still aqueous, plus bromine, which will now be dissolved in that water. And it's diatomic, so it's Br2. We just have to do a little balancing just to fill this out, a little two there and a two there, and we're all good. This is what we know as our single replacement or a displacement reaction. So the more reactive element will bond with the cation. And in this case, this cation is known as a spectator ion. So this may be a word you hear later on, spectator ion. What that basically means is that the aqueous ion, and it only really happens in aqueous reactions, the aqueous ion does not undergo changes in this reaction. So as a spectator ion, it's not going to make any changes. It just spectates. It kind of watches the chlorine come in and sweep away the bromine. Something to note here is that because the more reactive element will bond with the cation, if we take a look at a separate reaction, let's say the inverse, Br2 aqueous plus NaCl aqueous, this has no reaction because Cl is more reactive and already bonded with the cation. So this is about everything there is to know about group one and group two elements. So I hope this helps and have a great day.